Okay, short video lesson on solving two simultaneous linear equations. This topic in maths would perhaps better be described as to finding where the graphs of two linear relationships cross. So linear relationships are ones that produce straight line graphs. So it's as if we're finding where two straight line graphs cross. That's perhaps a better way of understanding this topic. So here's one linear relationship, and here's a second different linear relationship. If you were to plot these on a graph, this one starts from the 3 position on the y-axis and goes up very steeply. This one starts much higher up and has a gradient of 2, so this is much flatter. This one starts at 3 and goes up with a gradient of 10, so very steep. This one starts higher up and it's much flatter. So if you plotted those two linear relationships on a graph, the first one starts low and is very steep. The second one starts much higher and is a lot flatter. So they would inevitably cross somewhere. And our job in this topic in maths is to find the coordinates of the point where those two straight lines cross. So if the rules are both y equals rules, this is actually very easy, because where the two lines cross, so where these two lines cross, the y values, where they cross, where the two pens cross there, the y value must be the same. So what this would mean then is that where they cross, 10x plus 3 must be equal to 2x plus 27, 2x plus 27. So that gives us, from these two separate relationships, we now have one linear equation to solve. And we go about solving this in your normal preferred way for solving linear equations. So what I would do here is to take off and throw away 2x from both sides, giving that, which is then a lot easier to solve because I only have x on one side. So what I would do now, say with a cover-up method, it'd cover that up. So the only value that could be under my finger is 24. So 8x must be worth 24. And then if you cover that up, 8 lots of what is 24? 8 lots of 3 is 24, so x is 3. Because our job is to find where these two straight lines cross, we have to find the y coordinate as well. So knowing that x is 3, if we go back to one or other of these original relationships, we can find the y coordinate as well. So if x is 3, 10 lots of 3 is 30, plus the 3 is 33. So y would be 33. Or we can use this one if we wanted to. 2 lots of 3 is 6. 6 plus 27 is 33. So whether we use that relationship or that one, the y value is 33. So we now know the coordinates of the point where these two straight lines cross. But what happens if we're given two linear relationships like this and this? It's not then quite so easy to handle in that same way. So we have another way of handling or finding where two linear relationships cross. But we need to be clear about what we can and cannot do if we have some linear relationships. If we have, let's take one relationship. Let's say, for example, that the cost of an adult ticket and a child ticket is £20. So one adult and one child go to a ticket booth to buy tickets, and the cost of the adult ticket and the child ticket together is £20. We don't know what the adult ticket costs nor what the child ticket costs, but we do know about the relationship that the one adult ticket and one child ticket together cost £20. What we can then say is that 2 adult tickets and 2 child tickets would cost £40. So the relationship is still the same. This and this look different, but they are describing the same relationship. We haven't changed anything fundamentally. We could also say that the cost of one adult ticket is equal to £20, subtract the cost of a child ticket. So it's like I've subtracted C from both sides. Again, that really is telling us the same thing as that. It's still the same relationship. Another thing I could do is to square both sides, and it would still be the same relationship. Although all these 1, 2, 3, 4 look different, they are basically the same, describing the same relationship. Okay, so if we have a linear relationship, we can multiply throughout, divide throughout, add to both sides, subtract from both sides, even if you want to square or square root. And we have not changed the relationship. These are just different ways of writing it. One other thing we have to understand. So if we have this relationship and a different relationship, so one adult ticket and one child ticket cost 20, and then a family comes along and buys 2 adult tickets and 1 child ticket, and that costs £35. So one family, one relationship, a second family, and a second relationship. Is it true that 3 adult tickets and 2 child tickets will cost £55? Well, yes, it is. If they came to the ticket booth together and bought their tickets as one big group, 3 adult tickets and 2 child tickets would cost £55. What that shows is we can add together two different relationships can be added together. Is it also true, can we also figure out from these two, this family bought 1 adult ticket and 1 child ticket for £20. This family bought 2 adult tickets and 1 child ticket. So it means that they bought an additional adult ticket, and the cost of that must have been £15. So what we're kind of doing there, we can figure out that from that the adult ticket cost must be £15. So what we're kind of doing is a subtract. With this relationship and this one, we're effectively subtracting this relationship from this one. So if we have 2 different relationships, we can add them. And if we have 2 different relationships, we can subtract them. So if we go back to the problem we had a couple of minutes ago. So what I'm going to do, if we want to compare these 2 relationships, at the moment, there's nothing alike. In maths, generally, if you want to compare things, they have to be alike in some way. The number of adult tickets is different, and the number of child tickets is different. So what I've done here is, I've done something to make the number of child tickets alike. So I've left this relationship exactly the way it was. That one is totally unchanged. But what I've done here is I've taken this relationship, times that by 3, times that by 3, and times that by 3, which we saw a minute ago is something I'm allowed to do. The relationship looks different going from there to there, but it is the same relationship. Now that I have these 2 here, what I can do is compare them. So what's different is this family, if you like, bought 1 additional adult ticket, and it cost them an additional £24. So what I'm doing there is sort of like a subtract with the relationships. You might want to put in a line there and a line there. 3 lots of A, take away 2 lots of A is 1 lot of A, and 60 take away 36 is 24. So that enables me to see that the cost of an adult ticket is £24. The job isn't complete because I must work out also the value of the cost of the child ticket. So if we know that A is 24, if A is 24, the only value of, if that's 24, the only value of C that fits with that and makes it true would have to be -4. So I've done this deliberately. I've picked a pair of relationships which produce a negative result for one of the unknowns. Obviously, you might say, well, a child ticket can't cost a negative amount of money, but I did it just to make a point. That wouldn't normally happen if you were buying tickets, but sometimes when you're solving simultaneous equations, sometimes you may get one of the unknowns is positive and one is negative, okay? And these 2 values should both fit with this relationship. 2 lots of 24, 2 lots of 24 is 48. That would be -12. 48 plus -12 is 36. These 2 values fit with this relationship and with this at the same time. If we've got these two relationships here, what I would recommend doing is making the C quantities the same, so that in a minute I can add these 2. If I've got an add and a subtract here, I'm going to try and make them work for me. So what I've done with this relationship here, I've multiplied that by 3, that by 3, and that by 3. With this relationship, I've multiplied this by 2, that by 2, and that by 2. So this relationship has been rewritten as this, and it's still the same relationship, although it looks different. This relationship has been rewritten as this one, and it's still the same relationship, even though it looks different. But the reason why I did this was to make the number of C's alike. Because I want to make the plus and the minus, the add and the subtract signs work for me. What I'm now going to do, on the previous example, I did a subtract with the 2 relationships. Here I'm now going to do an add. You may want to imagine a line there, or draw a line there, and draw a line there. If I add these 2 relationships, which I'm allowed to do, we discussed that a few minutes ago. If I add these 2, 3a add 4a is 7a, Plus 6c subtract 6c is nothing. If we add these two, you get 126. So if we do a divide, 7 lots of what is 126? The A number has got to be 18. Our job isn't finished. We have to figure out what C is. So if A is 18, then C has got to be 0. So that's why there's C 0 there. And let's just check if that fits with this relationship as well. 2 lots of A, 2 lots of 18 is 36. 36 take away nothing is 36. So the adult ticket cost is 18 and the child ticket cost is 0. So unusual, but that's what's happened there. You couldn't tell that just by looking straight at those rules, but the algebra, handling it with the algebra has figured out that way. So to recap, sometimes if you have, in this situation where if everything is positive, where it's positive A, positive C, positive A amount, positive C amount, you can either make the A's alike or the C's alike. Here I chose to make the C's alike, but I could have made the A's alike. It doesn't matter. And then, so if they're all positive, then make either the A's or the C's alike, and then do a subtract. If you have something where you have a positive amount there and a negative amount, my recommendation is to make this the second unknown, make those alike, and then add the two relationships, simply because adding is easier. So I've made the C's alike and then done an add with the two relationships. 3a plus 4a is 7a. That add that is nothing. That add that is 126, and gone from there. And remember to find the values of both of the unknowns. Okay, that will do for now. Thank you.